All right, welcome back. We are COMP301 in the summer 2020 semester, and it's week 5, part 2 of our broadcast. We're still talking about bash, shell, and script programming, but as I said earlier to the class that was kind of online with me before we started, we're going to handle a few commands. One of them is going to be how to make arrays. I know I've had some questions around that. How to declare functions, how to take input into your script. That's important as well. And a couple of commands, the sed command and the awk command. And then what I want to talk about is how to install another Linux operating system, Ubuntu. And what I recommend for that before we start is download Ubuntu. I've given you the link on eCentennial, but you can simply go to ubuntu.com/download/desktop and download the latest version of Ubuntu. All right, so that takes a little bit of time. It's about 2.5 gigs at this point. So instead of us waiting for you to do this, you can start now and we'll come back to it. Again, as of this recording, Ubuntu is at 20.04 in the long-term support version. Okay, so it's not the bleeding edge version, but it's a good version. Okay. All right, so here we are with more bash, shell, and scripting. So I'm going to bring up my virtual machine here. So I've got me. There we go. And I'm going to go into activities. So we're going to go into our terminal. And in the terminal, we've talked about a few things. And one of the things I want to discuss now is how do I create an array? I kind of really touched upon it at a high level before, but I want to get back to it now because people were asking me questions through email. How do I do that? I didn't really get an idea. I don't understand how to use an array and so on. And so I want to kind of cover that one more time in order for you guys to feel better about how things are. So with an array, the best way to do is we start with the declare syntax. Okay, so there's two types of arrays typically that are used. One of them is an indexed array, and the other one is an associative array. So indexed array, you go declare, and as an example, you say -a, so lowercase a, and then the name of your array. And you have to do this before you actually allocate anything into it. If you don't, then it'll assume it's an indexed array. But let's suppose we're going to make a new array called my array. Okay, here's my array. And that's the first step. Make a name, but make sure it's you use the declare syntax, declare space -a, my array. Okay. And then if I had another array, if I was going to make it an associative array, it would be different syntax. -a, capital A, would be an associative array. So I would say something like my associative array. If I was going to use something large like that, I'm not going to, but let's suppose something like that. It's an associative array is like a map or a key where we can pass in key value pairs or a dictionary. All right, so I'd have a friendly name for the indices, as opposed to I got some weird feedback there just for a second. We can have friendly name for the indices as opposed to index values like 0, 1, 2, 3, 4. Okay, so that's what an associative array might look like. So for now we called it my associative array, but we're gonna obviously make something that's a little bit smaller than that. Okay. So the next part is really assigning values to the array. All right. So let's suppose I have my array, and just like a regular variable, we put the equal sign directly after, so no spaces. And this time we open a parenthesis, so a paren. Open a paren, and we can put values. And we use spaces for the delimiter, 1, 2, 3, 4, 5, as an example. And if I press enter, I've added 5 values to the array. Okay, and I could also add a 6th value to the array. So this is the way I can do the 5 values. So 0, 1, 2, 3, 4. And if I want to add a 5th element to the array, I can specify an element. I can do it this way. So I can say, element 5 is equal to 6. Okay, so that's how I add things to the array. And if I want to see the values of the array, I can literally just do an echo. So I can say echo again, $, but this time when I want to see the array, I'm going to use different syntax. So I'm going to use a curly brace to open up. So $ curly brace, and then from there, my array, and then square brackets, the @, which is kind of like a wildcard character, kind of, and then close square brackets, and then close curly brace. So that is the syntax. And if I do that, you can see that I got 1, 2, 3, 4, 5 from the first thing I did, and then I added 6 in the last one. Okay. The other way to add stuff to the array, because I can continue to add things to the array, is I can do a plus equals. Okay, so that's very interesting. So let's say, for example, I want to add 7 to the end of the array. It's actually like an append operation. So I can do simply like my array plus equals to 7. So that kind of says take my array, then add 7 to it, right? And so then if I do that command again, that echo command, you can see that 1 and 7 have been added on to the first one. So what it does, takes the first element of the array and adds 7 to it. Okay, so that's what it does, which is kind of interesting if I did it that way. But if I wanted to do it properly, let's try this again. So let's say, for example, I messed up there. If I go my array 0 is equal to 1, and if I do go back this again, you can see I've reassigned it to 1. Let's try that again. So my array plus equals to, and this time in brackets, in parens, if I put the value 7, right? And if I do that again, you can see there I got 1, 2, 3, 4, 5, 6, 7. So that's kind of the way I can add values to the array, right? And I can recall a specific value, just like I did here with the @ symbol. I can recall a specific value. For example, if I want the third element, so 0, 1, 2, 3, it would be the number 4, right? So if I said I want the third element of the array, so 0, 1, 2, 3, so the third, you would get number 4 because you do zero-based counting, so 0, 1, 2, 3. So that's how you do that, which is pretty simple. So that's kind of how you get elements. If I want to remove an element from an array, because you can add them, we can also remove an element or delete an element, and the way to do that is with the unset command. All right, so again, I would specify unset, and let's say I want to get rid of the second element of the array. I can go my array as an example. That's the second element, so that the first element, but it's actually element number 2, right? If I did this, unset my array, and if I wanted to see my entire array again, you can see that now that element has been removed. It's been popped out of the array, and the array has now reformed as 1, 3, 4, 5, 6, 7, right? And by the way, if I go echo my array, and if I look at element number 1 as an example, sorry, let's try that again. $. If I do that, one more time. If I do that, and I got to follow the proper syntax, my friends. Sorry, so many languages. If I do this, you can see that there is no 1, right? So my array 1, even though it shows 1, 3, 4, 5, 6, 7 in sequence, right? My array 1 doesn't exist. That value is gone. So I can actually do like my array 1 is equal to 2, or let's put 2 back in there. And then if I was to go back and see the value of my array again, we'd be back to 1, 2, 3, 4, 5, 6, 7. So you can see that even though I removed it, just because it showed it in sequence 1, 3, 4, 5, 6, 7, we'd be forgiven to think in some ways that array value for array the first element, or so the 1th element, that'd be the better way to declare it, right? The 1th element of the indexed array, my array, we would think it's a 3, but actually 2 is just empty. The second element, if you will, is empty, and so that way it just automatically shows the 3rd element in the sequence. Okay, so that's kind of what happens there. So that is that's kind of a very simple way of kind of declaring an array. And then after we declare an array, how to get, kind of how to do some simple manipulation with the array, which is basically adding, subtracting, and that kind of stuff, right? What also I could do is I could loop through the array. All right, so let's loop through the array. So if I was going to do that, so I would do a for loop. So we'll call it index, for index in. So for in, just like we did before, and then we can use quotation marks. So dollar sign, curly brace, this is the syntax. And then what I want to do is I want to use the exclamation operator, right? So I want to use, if I use the exclamation operator, actually it gives me a special effect. Let's try this out, my array. And if I want to use the @ symbol, right, again, close curly brace, close quotation marks, right? So I want to do this. And then what I do, and then what I want to do is echo the index, if I can spell index properly. And then I say done, then it'll give you the actual that's the index of the array, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. Right, so that's the index of the array. If instead I want to see the elements of the array, right? So I can do kind of something similar. I can say for I, again, in, and then I can say, dollar sign, curly brace, my array, right? So there's my array, and again, I'm going to pipe in the @ symbol, curly brace, exclamation mark, and then what I want to do, if I did this, and if I go do, and I do the same thing, echo index. So if I do the same thing and then done, here I would get 66666, right? Now why 66666? Why do you think I would get this? So for I, oh yeah, because done. Sorry, I did the wrong thing. That's why. I meant to do index, not I. Let's try this again. And then you get 1, 2, 3, 4, 5, 6, 7, which is what I want. There you go. Okay, does that make sense? Because of course I had index already predefined. So that's how you loop through. You can get either, I just showed you there how to get the actual index value itself, or how I'm going to get the actual value of the array. So that's like for an index type array. Okay. Any questions around that? And again, this is just a basic understanding of how arrays would work. I think you guys were asking for this, and I wanted to make sure that we had the same thing. So then the next part, let's clear that. If I was going to talk about arrays, is remember we declared that associative array. So if I kind of echo the value of my associative array, you can see that there's no value right now, right? Because I haven't really done anything with it. I've just declared it. But let's just declare a smaller one so we don't have to type all that. I certainly don't want to do that. So -a for associative array, and we'll just call this, we'll just call it the same thing. So my array. Okay, so my array. So we made it, and see what it says. We wanted to do, we can't convert from one array to the other because we've already made an associative array. So what we could do again instead is, what if I tried unsetting my array? So if I said unset my array, and then if I tried doing this again, then I'm good to go, right? So I can unset a variable, which basically deletes it or removes a pointer to the array memory location, right? So here I got declare -a my array. My array is now an associative array, and what I have to do this time, instead of me setting up my array, let's set up the values that I want to put in. So I want to say something like, let's set some values like Monday is equal to Monday, Tuesday is equal to Tuesday, and so on. So if I said that, if I said something like my array, and then square brackets Monday, right? And then if I said that's equal to, we'll call it something else. Let's say Monday. But I mean, again, if I press quotation marks here, the quotation marks aren't going to really matter. But it won't show up if I did this, right? And if I said my array Tuesday is equal to Tuesday, Actually, we'll do that. We'll do lowercase for the second one, just to show you that there's a difference. And my array Wednesday, you can see there's no rhyme or reason for how we have to do it, right? It's equal to Wednesday. And then if I did that my array syntax again, so I want to echo $my array just by itself, nothing. But if I did echo, and just like I did before, if I scope up, and again you can remember the previous commands by kind of going up to this. So this is my array, echo my array. Then you're going to see Tuesday, Monday, Wednesday. Okay, interesting how that would work out. Notice that there is no index. It doesn't work out in a specific pattern or anything. It's not like we declared Tuesday first or anything like that. It just responded the way it would store locations in memory for us. Okay. One thing to note is that the way it would do it is based on alphabetical order, where lowercase characters come before uppercase characters. All right. So Tuesday, you can see that that is a lowercase character. Let's make another one. Let's say we made it a special day, right? So we'll call it any day. How about that? My array any day, right, is equal to special. There we go. And if I was to do that command again that we just did, you can see that special comes after Monday, but after Tuesday as well. And notice that there is no rhyme or reason for this again, right? It's not like any day itself is coming anytime soon. But my index, any day, is a capital A, any day, which is interesting, right? So Monday, Tuesday, Wednesday. So now let's say if I wanted to get a value back, and if I said, okay, well, I want to get the value of an array element back. I want the array element for Tuesday, right, as an example, then you can see it gives me Tuesday back. If I want the array element for any day, right, then I get special back, because that's what I've done. So that's the way you kind of you would store and you retrieve values from the array. And just like before, if I was to unset a value, so if I said unset something like, my array, and then let's say Tuesday, and if I try to get that value back, so let's say echo Tuesday, then I'm going to get no value. So that value doesn't exist anymore. So I can set and unset things. All right, so that's like associative arrays. And if I want to delete, by the way, if I want to delete the entire array, that's another thing I got to show you how to do that as well. Let's say I want to delete everything, then I would do one thing I can do is just like I did before, unset and whatever my array is called. Okay, so that's deleting the entire array. Okay, questions around arrays and associative arrays. So regular arrays, indexed arrays, and associative arrays. And you need to know how to get that back. The next one is if you want to make functions. So the first part was arrays, and now we're going to make functions happen. How do I do functions? Well, you just make a function. So let's say, for example, I call this my function. And you start it with a curly brace. So if I did this, now it's listening for additional things. Let's say, for example, my function, I want to echo, kind of hello. This is my function. All right, that's what I want to echo. And then I want to close the curly brace. So there it is, done. The way to call the function is just by the name, no brackets. So my function. So if I just did this, you can see hello, this is my function, right? So that's how you make a function. That's how you call a function. You don't use the parens when you're calling a function. This is just a review so that you know how to do this. But what about if I want my function to take parameters? How do I do that? There is no formal way. I don't take named parameters. My function can take unlimited parameters. It's almost like a variated parameter list. All right. So what that means is that I get a bunch of arguments, and it's unlimited number of arguments. Let's say, right? So I get all these arguments, and then what I do from those arguments is I can respond to them. And the way to get the arguments, the values of the arguments, is $sign and the number. So it starts with $1. So $1 is the first argument. $2 is the second argument. $3 and so on. If I use $0, I get the function itself. So for example, if I do my function and then let's redeclare it. So I'm doing my function again, my function, and this time I want to echo $0, right? And then I also want to echo let's say your name is. So I say your name is, and then $1, and I can say echo. I'll say but my name is $2, right? So I can say that, and then I will close the curly brace, right? So there we go. So now it's expecting input, right? So if I do something like my function, and then if I just press enter, you can see it'll return bash, right? Which is interesting. And the other thing it'll return is your name is, my name is, and so on, right? But if I actually end up if I add some variables, so arguments to this thing, so I can say Tom and Mike and press enter, it says your name is Tom, but my name is Mike, right? So that's how it does. It takes the $1 and $2, $0 is bash, which is reserved, okay? So in this way, if we think about functions working this way, scripts can also work in the exact same way. So think about the entire script taking an argument the same way, right? So how does this work? So if I was to make a script, so if I look at my my documents now, so if I go and I want to make this in documents again, so there's my documents, and let's make another workspace. So I'm just for practice, make directory workspace 5. Right, here's my workspace 5. There we are. And I want to make a new script, so I'm going to call it new script 5. Let's just say. So again, I want to use the touch keyword, touch new script 5.sh, right? And I want to use code to modify it, new script 5.sh, right? Then code's going to come up, Visual Studio Code, and then what I'm going to do is again, it's shebang / bin bash. That's the first. Those are the first lines of my script every time. I'm going to put a hashtag and let's say author, right? So that's me. Some kind of description of what this thing is, right? So maybe the date, and then today is June 25th, 2020. Wow, it's getting on, eh? And I'm also going to put maybe a description, script demonstrating arguments from the command line, right? And then let's say do the same thing. So I'm going to say that when I enter something, I want to echo out, and then we'll say -n, so no new line character, and I'll say you entered, and then let's take a single argument, right, which is $1, and then we'll just end that script. That'll be enough, right? So if I press Control S here, that's all I want to do. I just want to prove to you that I can get input from the command line this way, right? So if I did this, and if I now, the next step, remember, is to do what? What do I need to do next to make this script usable? There's actually a couple of things I can do, but what's the one thing I should do? You guys should know this by now because I've talked about it a bunch of times. It might be in a test. Make it executable. Thank you. That's the exact right answer. So again, if I look at my scripts folder right now, so this is new script.sh. I want to make this executable, and the easiest way to do that would be the change mode command plus X. I'm adding X permissions to run the script to user, group, and other. That's what I'm doing for everybody, basically, to do that. I'm going to specify the script, right? And then once I've done that, you can see now that's clearly executable. It's also green. That's a good indicator in bash, but the X's are now there, XXX, right, as an example. Whereas before up here they weren't, so it wasn't executable before, but now they are down in here. And then I can run it by /new script 5.sh, and it's waiting for input as an example. So I'll say Tom, and then it's going to say you entered Tom. Now notice I said that I also used the -n, which actually didn't give me a new line character, right? So if I was going to edit that, new script, and let's do some additional things. You entered this, and then we'll say, we'll keep going, and you also entered $2, if there's such a thing. So I'm expecting 2 inputs here as an example. And then if this is true, I want to do a \n. \n. Now \n means that if I just did this, right, then -n says that it's not going to do a new line character. But can I do a -en? E for I want to accept new line or special characters. N, I don't want to include an automatic / character, or sorry, new line character with echo, because that's what echo does. It gives you automatically a / character. So let's try this out and see if it works. If it doesn't, we'll know, right? So again, I want to execute that script. So I want to say Tom and Mike, like I said before. And if I do this, it says you entered Tom and you also entered Mike. So those are 2 things. I got that from the command line. So now we're getting input. We can get input for the command line. And now, my friends, we have mostly everything we need to get to make this script really useful. Because if I can enter data into the script, and I can also push stuff into the script. So if I said list of names, let's say, for example, let's make a text file. So touch, say names.txt, right? And we'll code that. And when we do this names.txt, let's add a few names to the different lines here. So I want to say that I have a name, Tom, Mike. Be careful here. I've got a bunch of names, Tom, Mike, and I don't know, we'll say Cherry and Sarah, right? So we have some names, a few names here. And then I want to, is it okay that I pipe those names into my new script? So can I do that? So I can say, can I say that names.txt, I want to pipe it, so the pipe character or redirect character is this, pipe it into /newscript.sh, and then it says no, right? So one thing that it doesn't do, right now it's not prepared to do this kind of thing, this interaction. And I wanted to kind of talk about this because one of the things you might try and do is exactly this, right? So .newscript. But can I do it a different way? So what if I said names.txt, and then what if I did bash newscript.sh? Does that work, right? So I'm getting some names, and then it doesn't even take anything, right? Because I'm not getting it from the command line, as an example. I'm actually getting it from a file, right? So that's something that's weird. But for sure, any kind of input from the command line itself, like if I have like 20 different elements, so let's say, for example, I said something like, I can also run a script with source, right? So new script 5.sh, and I said Tom, Mike, Cherry, Sarah, right? Then all we care about is number 1 and number 2. We don't really care about Cherry and Sarah. Cherry and Sarah are just discarded. They're just ignored, if you will. And actually, this is how JavaScript works as well. Functions in JavaScript, I'm just making a reference to this because I know you guys are learning JavaScript as well. If I pass in 20 different parameters to JavaScript, but I'm only listening for 2, the rest are discarded, right? Actually, sorry, let me take that back. The rest are actually put into an arguments array. And if we want to access it, we can access it. But for the most part, we ignore them unless we specify we want them. Here, it's actually discarded, like they're just chopped off. All right, so ways of getting it back. Okay, I'm moving on now to the sed command. So the sed command is it's like a substitute command. That's usually what you use sed for. So let's say, for example, I want to look at names.txt, and I want to replace. I want to replace a name that I have in there, Tom, with another name. Let's say capital T Tom instead of lowercase Tom. right? And if we did a cat names.text, you can see I've got Tom, Mike, Cherry, and Sarah. Let's replace Tom with all caps Tom, right? So the way sed works, I can go sed, and then what I have to do with sed is kind of a single quote or double quote, and then the first command is S for substitute slash what I'm looking for. So this is kind of a search syntax. I'm looking for Tom, and I'm replacing with Tom. Okay, so that's what I want to do. And where am I getting the input from? Well, I'm getting it from names.text. So if I was to do that, sorry, it says minus E expression number 1, character 9, unterminated S command, right? And this is important because what I didn't do is put a another forward slash. So I could do the same thing. The only thing I was missing here is this. That's what it's looking for. And now it does that. It says names.text Tom I replaced Tom with Tom, like all caps. But if I actually did a cat, right, it didn't replace. It didn't actually change anything. It's the output that it redirects. So it's like, okay, get names.text, just like cat, but instead of I'm searching for a pattern like Tom, and I want to replace Tom with Tom, and then I can redirect that output somewhere else. I can say, well, let's make it new names.text. So I can kind of do the same thing right here. And then what if I pipe this into new names.text, right? So then if I did that, and if I did a cat new names.text, you can see now that I have Tom officially there, right? So sed is really, really powerful. You can do a lot of stuff with sed, and if we did a man sed, it's the stream editor, and that's what it does. It actually is another way. The two commands I'm talking about now are filters. That's what they are. They take your input, they filter them in some way, and they spit out something else, or they return, kind of data similar to finding something or a search pattern. Right now, you can use different kind of search criteria. You can use regular expressions here if you want, or you can use the syntax I just showed you. There are a ton of ways of using the sed command that there's no way that I can cover all of them today. But basically, it's amazing. Let's say, for example, I wanted to replace the, so if you notice the details here, so sed, whatever options I want, you can see that there's and minus M for quiet or silent, minus E for an expression, right? I can put that minus E in there. There's also other switches, right? As an example, follow symlinks and a bunch of other stuff. And then the great thing about sed is it has like so many different things here. So if I go to S, here's what it looks like. So here's S, so search for or substitute, a regular expression or some kind of pattern is what I'm looking for, and then whatever the replacement is. So that's just one way of doing things. And then what I can also do is I can look at that same pattern and I can do a global replacement as an example, as opposed to, so I can at the end of my replacement, so there's a couple of additional features I can use for this one. So there's a couple things. So one thing is that I can replace the nth occurrence with a particular pattern, right? So let's just go back and go to code. Okay, so let's do this, and now you can see this is the original file again. Tom, Mike, Cherry, Sarah, and Tom. We'll put Tom again, and let's put in some additional names in here like Gary and Steve, and a bunch of other ones. You can put whatever you want, and let's put Tom in again one more time. So I got like Tom in 3 times, right? So what I can do is I can do the same replacement. I can say that let's go and replace Tom with capital Tom, but I want to do it on the second occurrence of this particular thing. So if I did this, And if I looked at new names.txt now, so if I said cat new names.txt, you can see that, well, none of that happened. Second occurrence, which is not what I expected, actually. It's supposed to actually, replace that particular value in a line, right? So that's what it's supposed to do, right? But I think what it's looking for is in a line, not in a particular file. Unless I wanted to replace all of them in a particular file, then I would use the G command. So if I said, I want to replace all toms that I find, not just one, so if I just took this away like this, and I did that again as an example, and if I went to new names.txt, it clobbered the other new names.txt, right? So if I go to cat new names.txt, right, you can see now all occurrences of Tom have been replaced, right? Each one of them, it searches for each line of the occurrence and replaces them all, right? So that's something that can happen, right? So, but if I had a line, this is for each line. It looks through each line and replaces the first occurrence per line, right? So let's go back to names.txt. So if I was to look at this again, and if I say something like, I don't know, we'll make something else up. Instead of Tom, we'll use Mike. Mike is a good student. Mike is also a mechanic. I don't know, making this up. You can see that there's two occurrences of the word Mike inside the same line, right? And so now what I can do is I can use that second occurrence stuff. So I can go back to this. Let's replace Mike with Mike, but only for the second occurrence. Right, so if I did this, and then if I want to look at cat new names, then you can see that the second occurrence of Mike is now has been replaced. But if I wanted both of them to be replaced, right, and if I did that, if I said something like, well, so if I just did this, so none of that, and let's just look at that now, you can see that Mike has only been replaced in the first occurrence, but not the second one, right? The first time I see Mike on a line, I replace it as an example. But I want to replace all occurrences of Mike, right? So I can just go here. And then if I put the G after this again, so after I have my regular expression, here's the expression, the thing I'm looking for. Here's my replacement, and here's a value as an option, as an example. And if I did that now, and if I looked at this, you can see now that both occurrences, all occurrences of Mike, and if I had more occurrences down here in the file, globally it would replace those occurrences. So that's set, and there's a bunch of other things that set can do. All right, so like tons and tons of things. That's pretty cool. The next one I want to handle is awk. Okay, so awk is actually in your documentation in the PowerPoint, right? So awk is, how do I explain awk? It's been a long time, but basically what it is I can make little statements and little abbreviations. What it does is awk does a few things. It looks at the file line by line, and it splits up each line into fields. So for example, I have a bunch of, let's say for example, I have awk and then some options. Actually, let me look at the man, and I'll show you what the man looks like. Man, awk. So you can say that awk or gawk, in this case, is the implementation of the awk programming language, and it conforms to the definition of the language in the POSIX 1003.1 standard. And what it does, it talks about how it works. It accepts the following options. So -F for program file, for file system, -V for, as an example, for variable and value, -B for characters as bytes, and a bunch of other stuff. There's tons and tons of options that awk takes, and it is like a little programming language. So it takes, again, scans the file line by line, each line, all right, and then splits input lines into fields. So if I take the lines, as an example, let's say I look at a line like we had in names.txt, right? And then I can compare lines. I'm trying to describe this thing. Compare lines to a specific pattern, and then any of the lines that match my pattern, I can do some kind of action. So things like if I want to transform a file, if I want to produce a format that, let's say I want to format some kind of report in a specific way or something like that, awk basically scans the entire file that way. It's like very similar to sed, but what it does is very different. So so again, if I was to if I want to look at each of the files, let's say if I just did an awk command by itself, let's say, and so nothing, I don't put anything in there, so I said awk and then names.txt, right? And then it says that awk command line 1 names.txt syntax error. It doesn't know what that is. But if I was to say that awk and then in curly braces, I want to print. This is kind of interesting. Actually, it's a command. So awk, I want to print every line of the file. I execute the print command on names.txt. Then it looks very similar to a cat command. That's what it does. So it actually prints every line of the file, right? So awk is huge. Awk is very powerful, and it has a ton of subcommands that you can use, right? So let's suppose I want to match a specific pattern. I want to print all lines that have Mike in them, right? As an example, Mike is a good student. Mike's also a mechanic. There's only one line like that that'll match. So I can do something like awk. I want to match kind of a pattern, Mike. So there's my match, right? Let's go back and do that again. Awk, Mike, that's the regular expression, right? And then what I want to do is I want to print. So that's what I'm going to do with the match. So I match something, and then I do an operation on it. And then where am I getting that from? Names.txt. So you can say Mike is a good student. Mike is also a mechanic. I can specifically say look for Mike inside my file. I want to print Mike, right? So I want to, kind of, that kind of stuff. And then, that's what I'm looking for, right? And then print is the command. And let's say, for example, I had more lines like that. So let's say code names.txt. And let's add some additional information. Tom is a professor, right? Cherry is also a student. Sarah is a scientist. There we go, scientist. Tom is also a student. We'll say these are all isas, right? Gary is an astronaut. If I can spell astronaut properly. Astronaut, yeah, that's how you spell it. Steve is a writer. And we'll say Tom is also a gamer. All right, there we go. So there's some lines of, of statements, right? So we'll save those. So we see that is a, and then there's something, whatever that is, right? And one thing that is interesting is here in is good student, we have a modifier to student called, which is good. Let us take good away. We'll just say Mike is a student. Mike is also a mechanic, right? And we'll put that's the one line that we have kind of things that as a pattern. But we have Tom and then Mike and Cherry and Sarah and then a bunch of these things and is a, and then followed by some kind of profession or a role or something that the person does, right? So if I have that, then what I can do is I can separate the lines into fields. So I can say something like awk, right? And again, it's print, and then remember that $ stuff, $1, 2, 3, 4. Those, it's almost like I'm looking at different parts of my input, and I only care for, let's say, so the name of the person, so $1, that's the first field in that line, typically, right? And then their profession, right? So $4, let's say, right? And then we can look at, and I think I'm doing this wrong, of course, because I got to put curly braces in here. And then, of course, the input names.text. And you can see that Tom, professor, Mike's student. And one thing that we notice is that there is no separation. If I want separation, then I could use a comma for this, right? And oh, nice. Did I freeze? I froze. Let's try that again. That's okay, because the great thing is, I love when that happens. Yes. But I have to be in the right folder. So let's get into the right folder first. So again, notice by default it takes me here. I want to go to Documents, Workspace 4. There, now I can do that command. Oh, that's interesting. Where is what? What? Well, that's very interesting. So it kind of I love VMs. It kind of killed my my names.txt altogether, which is kind of weird, which kind of sucks. But anyways, you get the point. The point is I can get. I'm not going to recreate that right now. That's going to take too long. But more or less, that will take each of those fields, each of those lines. Actually, let's just do it again. Hopefully, if I press code, then maybe it'll have. It does. It does. So, yeah, that's really interesting. And if I press save, let's see if it actually does that. Save. And where did it save it? I think that's interesting. I want to see where that saves it. Names.txt. Let's go into Documents, and let's go into Workspace. Okay, Workspace 5. Oh, there we are. Workspace 5 is where I was. In the wrong workspace. Okay, so excellent. And what I meant to do is, if I go back to this and I just add a comma, so comma, then what we should see, if I did everything right, is exactly that. Tom, professor, Mike, student, Cherry, okay, that's interesting that Cherry, Tom, right? Because it's interesting that I don't get also in there, right? So again, notice that what I'm looking for is for the fourth variable. So 1, 2, 3, 4, 1, 2, 3, 4, right? I got to this point, and then things started messing up, right? And then I didn't get this part, right? So this part was ignored. Then it gave me 1, 2, 3, 4. So so is also I got Sarah, it gave me exactly what it says. It did exactly what I asked it to do. Sarah, 2, 3, 4, scientist. Tom, 2, 3, 4, Gary, 1, 2, 3, 4. So Gary, astronaut, right? Steve, writer, and then Tom, right? So that's interesting how it did that, because of the way that I formatted the file. Okay, so that's kind of some things you can do. And there's a ton of other things that awk can do, a ton, like really a ton. And like I said, we could spend pretty much the remainder of the lesson on just awk, right, and what all the stuff it can do. I highly recommend if you're going to use something like awk, and if you want to find, replace, and print. One thing that awk is very powerful at is that I don't want to do this, that's for sure. I meant to do this. One thing that awk is very powerful at is not only can you do this, but you can also pipe it into some other thing, like new names .text. So what it can do is it can output everything into a kind of, like we said before, some kind of, if I want to cat new names .text, it can pipe it into somewhere else where you can save the output, save your results into a formatted report if you want to search for and replace certain things and so on. And again, I think it's really, really powerful, and there's many, many other kinds of commands. All right, so questions about what you can do with awk and what you can do with sed. Those are pretty powerful things. And we talked just now how to do arrays, indexed arrays, how to use associative arrays, how to use functions, how to get input from the command line, how to use sed and awk. So those are the things we've covered now. And I think that covers most of what you need for this intro into bash scripting, which is what this is this semester so far. All right, cool. So for now, let's take a break on this. And we're kind of halfway through. And this is where we're going to explore a new operating system. Okay, I won't do it too long. I'll see if we can end earlier. I'll try, I swear. Okay, I know I keep saying that sometimes, and we go on these tangents, but let's power off this one. So I'm going to power off this one, right? So I'm going to power off, and I'm just going to shut this down as well. And what I want to do here is I want to bring up Virtualbox. So here's Virtualbox, and I want to create a new virtual machine. And I did one for SteamOS. I want to do that one for Ubuntu, right? You're going to notice the steps are very similar to setting up, but then when we get there, there's some other questions we have to look at, and also some other options we have to initialize. Okay, so again, I've already gone ahead, and if you look at here for Ubuntu, I've already downloaded Ubuntu, so you should have done this by now. Have you guys done this? Have you guys downloaded Ubuntu? Is it finished for you? Check mark for yes, X for no. I want to make sure you guys are on the same page as me. I got no response. Guys, are you there? Check mark for yes, X for no. How about this? Can you hear me, guys? Check mark for yes. Hey, I got someone hearing me. That's awesome. But how about downloading? Did you download this thing already? Check mark for yes, X for no. Some people are check marked and some people didn't. Yay, X for no. Come on, Joseph, download it already. Okay, so I'm going to go through it anyway. Maybe you guys haven't had a chance to do it, or it takes time for you guys to do this. I'm just going to clear all this stuff. But I've already downloaded it. It's right here, and it's in my downloads. And I'm going to go back to my virtual machine. Here it is, and I'm going to make a new virtual machine. Yay. We're going to call this Ubuntu. Everyone pronounces this differently. Ubuntu, different things like that. But notice as soon as I put the name Ubuntu in there, it suggests Ubuntu 64-bit. And just like before, I want to allocate something like half my memory. So I'm going to go to, let's make it 8192. Let's say 8 megs, or 8 gigs, I mean. All right, the next one is create a virtual hard disk. This is the same part as before. We can specify where the machine folder is going to be. I want to create. It's also going to tell me the file location. So if I want to specify a specific spot for this to be in, I can specify a spot somewhere else, like for example on my F drive in VMs. It could be here, right? Save. And then I can specify the amount of space. Let's suppose, again, I allocate something like 100 gigabytes. You can actually type it in there as well. 100. Doesn't like anything less than 100.7 for some reason, but it's okay. I'm fine with that. And I'm going to make it dynamically allocate because I don't want to use 100 gigs of space for nothing. This is for this little demonstration. I'm going to click create. All right, so I've kind of allocated some space for it. That's what I've done here. And what I want to do now is modify the settings as before. So I want to go into settings for this virtual machine. And again, a couple things. I want to enable a shared clipboard. I like doing that. I think that's very useful when you set up a virtual machine. I also want to, I don't really need a floppy. I do need an optical drive, right, as an example, for sure. It says this is the boot order, so I don't care about floppies, that's for sure, but these are good. I'm not going to use EFI. From a base memory perspective, you can always modify it again here. Processing-wise, I recommend if you have a multi-core processor, you allocate at least a couple cores. I'm just going to give it 2. You know, because I have like, it looks like I have 12 CPUs available, which is actually 12. My processor is multi-core, multi-threaded. It's got 6 cores, but 12 threads. It's an older version of the i9 that I have. That's the one that I have. Acceleration is on by default. My display, this is where, you know, I've learned that you probably want to put this up as much as possible if you're going to do anything that's decent. Monitor count, I'm not going to change. I'm going to definitely enable 3D acceleration. If it's possible, I will. No need to modify remote display or recording. Storage. This is kind of the same thing we had last time, where I click on empty and I select my, I'll make this master, primary master, and I want to select my, my disk. So I'm going to go to choose a disk file, and I'm going to look at Ubuntu. This is the thing I just downloaded today, and open. So that is the disk file that's going to kick off my installation. That's what's happening there. I'm going to go to network, and I'm going to immediately go to bridged, because I know that that's the way I want to do my network, right? And for the most part, I've done everything I want to do. Press OK. So now I've configured my virtual machine, just like we've done before in the past. There should be no difference now between this, our installation, the way we did it, except for memory, maybe allocation, whatever. I want to start my virtual machine. And now it's a matter of following the prompts, just like before, if we did everything correctly. All right, so it says, do you want to select the startup disk? I want to do this one. I'm going to click start. It's going to give me an option to set up, like normal. Okay, and we're just going to get out of here. So just give it some time as it goes through, and it's going to check my disks. It's a little different of an installation type. Remember, one thing to note is our Ubuntu is definitely going to have a different file system. The way the file system might be is very similar, but our command line and our is going to be bash, but our desktop is going to be different. It's not going to look the same for the most part as GNOME desktop. Not the same exactly. One thing I like about Ubuntu is, in my opinion, is it reminds me a lot of Windows, right? In terms of the way it can be laid out. You have a lot of really cool control on it, and as a replacement for Windows, I might choose Ubuntu, you know, as opposed to Fedora, right? I think Ubuntu is a very common Linux distribution, and you're going to see a lot of people use Ubuntu as compared to Fedora. So give it a sec. It's still in its installation phase. It's usually see something different. Look at that. I even get sound pretty much immediately compared to what I had before, and it gives me a little installation wizard. Okay, I don't want to try Ubuntu. If I try Ubuntu, that means it's going to just run it once, and it'll never install it. I want to install Ubuntu, right? So just like we did last time with Fedora, I want to install it. It tells me the language and the keyboard preferences that I want to have. I want to continue. I'm actually following a little wizard here. This is kind of what I like about Ubuntu. Okay, it tells me what do I want to do. Do I want to do a normal installation? Do I want to do a minimal installation? If I do a minimal installation, it doesn't install all the software, games, media, and all that stuff. Other options is download updates while installing Ubuntu. I think this is a great installation option. The other one is install third-party software for graphics and Wi-Fi hardware and additional media formats. That would be great if I was going to do this on the Metal. I'm not going to do that. I'm going to click continue. Because again, remember that a lot of my hardware is virtualized, right? So, or most of it is, right? So it's like, you know, we got to chillax on this thing, right? If we did this, then what would end up happening is even this, to be honest with you, is overkill. It's going to increase our installation time a little bit, right? So it's doing its thing, and one thing I like about it is it gives me a little bit of feedback as a user. For me, user experience is important, right? So I'm getting back a little bit of feedback. Okay, so this is good. So it says erase disk and install Ubuntu. Warning, this will delete your programs, documents, and blah, blah, blah. And this is what we want because we don't have anything. We don't have a disk that's usable right now. So I'm going to click install now. Okay. And then it says, if you continue, the changes listed below will be permanent. Do you want this to happen? I'm going to say continue. And it's going to go through and delete stuff. Remember, this is pretty cool. It automatically detects my my time zone, which is awesome. Toronto, right? Continue. Why? Because I've got a bridged adapter from the get-go. I started with a bridged adapter, not a NAT. And it's connected to the internet for me. Okay, so now is something similar that we've done before. So my name, so let's say is Tom. If I can spell my name, that'd be nice. Okay, your computer's name, Tom Virtualbox. Well, we can say Linux PC, right? And we might want to say Ubuntu PC instead of Linux, so I can identify what that is. Pick a username. We're going to pick Tom. I'm going to choose a password, the same one as I did before. And it's not going to like that. It says fair, because I'm making a very simple password. One thing it says, gives me an option right away, log in automatically, so I don't have to log in every single time that I launch my thing, and that's a good option for me. And then, or require my password. I like requiring my password for security reasons. Continue. And yeah, right? So this is where, if I was going to tell you to replace your operating system, your Windows operating system with Linux, I don't know, I might use Ubuntu. Ubuntu is kind of a really good installation option, right? Especially if you're going to do it, like actually run Ubuntu on your machine. One of the other thing it does, that third-party installation stuff, it does detect a lot of your devices out of the box. So it makes it quite straightforward to install Ubuntu. In fact, you can run and install Linux within minutes compared to Windows. Think about this. Like, this is actually doing it. How long does it take to install Windows 10 nowadays? Not quite this fast. Let's put it that way. Not quite this fast at all. And it installs all kinds of useful programs right out of the box, right? As an example, compared to what you get with Fedora, right? So that's where I think I like it. I'm gonna wait till this is done here. So I like the cat too, that's for sure. And this is where I think it's where Fedora is a little bit more bare bones, right? If you want a little desktop, a workstation to connect to a server, you might choose Fedora because it's like really lightweight. But then again, you could have chosen the minimal installation for Ubuntu as opposed to the full installation, right? So notice I get some of the same stuff: Rhythmbox, music player, Spotify, VLC media player. I don't have to download that. That's my favorite media player that I use, even on Windows. Now the difference is, and this is what's happening here, is it's actually downloading files, and you can see that it's actually going through and uploading or updating the system as we go. And you notice that there's a skip option, so I can skip through this and I don't have to install. I've already installed everything I need to install at this point. Because skip has shown up, I can literally click that button and I don't have to install all my updates at this point if I don't want to. I can wait, and what this will do is it'll stop the installation of the extra stuff and then finish what I've got going on right now. Okay, so that's pretty good, right? For from a user experience perspective. Look at this. I'm getting other stuff: supported software, GIMP image editor, shortcut video editor, and a bunch of other stuff. Different language packs that I'm getting. Of course, I'm installing LibreOffice because that's a really standard installation option module. And this is really good. I don't know what it is. For me, Ubuntu makes me happy. I don't know what it is. Fedora makes me kind of happy, but Ubuntu really makes me happy with what it comes with. So as opposed to what the basic things that you get with Fedora. So how about yours? Is your installation going as quick as mine? Again, it really depends on your system, what resources you've allocated to it. Your download speeds is important to your bandwidth, and Thunderbird is really cool. Thunderbird, think about that. Out of the box, you get Firefox and Thunderbird is a mail client, so that's really cool. And so you have a mail client you can install instead of Microsoft Office that can connect to most of the things that you want, right? So a true alternative to doing stuff. And then one thing that Linux is really getting good with is there's a lot of games for Linux out of the box. So if you're someone who enjoys playing games with Steam, there's a lot of compatible games that are ready to go on Linux as soon as you've got your hardware configured. There's also a claim, and I got to put it out there as well, and I want to see what you think about this. There's a claim that Linux will run things faster. So if I want to run a process or a other things, your system will run faster with Linux, and especially on older hardware. Like Linux doesn't require all the hardware that Windows requires. We've seen that already. I mean, I can run Linux with 4 gigabytes, right? And let me ask you this question. Do you think you can run Windows with 4 gigabytes? And what do you think? Check mark if you think it's true, X if you think it's wrong, right? Especially Windows 10, 64-bit. What do you think? Your answer should be an X, yeah, because there's no way you can run Windows properly. Sure, you can maybe run it, but it would run super slow. So Windows is it's a big operating system with stuff. Even on Mac OS now, and I know recently on Monday they announced that Mac OS is changing. Mac OS Big Sur is coming out. Again, its base operating system or kernel is kind of like based on the Darwin Linux kernel, another distribution of Linux, which is different than the distributions we're talking about here. But they're moving from Intel processors to ARM-based processors, and the scuttlebutt on this is that you won't be able to run Windows in a virtual machine that'll even run on Mac anymore. Whereas before, through Parallels, you could run Windows no problem. And I'm wondering if that's going to be true. If you ran something like VMware, would it still be able to accept Windows? Because it doesn't really matter what the bottom line architecture is. That's why virtualization is great. We don't care what the hardware is. It'll just virtualize what you have. So I haven't heard anything about that, but it's moving away from Intel-based processors over the next 2 years. That's what they're doing with Mac software. But even Mac OS right now, if you ran Mac OS Catalina, the current version of the operating system, and you try to run it with something like 4 gigabytes, yeah, it's going to be like super slow for you to run it with 4 gigabytes, like super slow. So but where Linux can do it. I mean, and it runs it because remember what's happening is the UI that is kind of on top of the command line is so lightweight, right, for Linux compared to other operating systems, Mac and Windows, Mac OS and Windows, that it'll actually run with a lot fewer resources. So that's where developers are excited about running a Linux operating system, even as a dual boot. Okay, so dual booting means that when you kick off your laptop or your desktop, it'll give you an option. It'll come up and say, so which operating system do you want to run, Tom? Do you want to run Linux or Windows? As an example. And it'll run it on the metal. So super fast, right? Linux is, like we said before, secure. Some people claim it's more secure than Windows as well, because it's not moderated by Microsoft anywhere else. So Microsoft isn't like looking at your system, and it's not pushing updates to you that you don't want to download. And all the distributions for Linux, for the most part, are free, right? Well, most of them. So at the end of the day, you're looking at a free operating system that you get with your hardware. It supports all older hardware, and it supports hardware that has lower specs, right? So that means you can you can make use of some of that old stuff that you have lying around, and make it into a little server. Let's say for even a media server, Linux is great for that. Let's restart now. I'm done my installation. So it's going to restart once and let it do its thing. Okay. And it says, please remove the installation medium and then press enter. So the way to do that, remember, is we want to go to the to here. I want to shut this down for a second, right? So it says shut down, power off the machine, right? Just like we did before. So we'll power off the machine, and then we're going to go to our settings. So I powered it off by pressing the X. Go to the settings, and then go to storage, just like we did before. And notice that it says empty now. This is good, right? Because it removed it for me. Like VirtualBox was smart enough to take it away. Before, we had to actually go in there for Fedora and remove it manually, right? By removing it. But here it's just done it for me, right? So now it's done. The installation media is done, and I can just start Ubuntu again, kind of like a restart right from the get-go. So this is good. This is really good compared to the experience I got with Fedora so far, right? So it goes through it, and now it's loading up Ubuntu for the first time officially, and it's going to ask me to log in, like before, and all that kind of stuff. So, and now after this, I'm going to get you guys to give me some feedback. You know, what do you think after this? I want you to explore the system just for a few minutes, so you don't want to spend too much time doing this. And then tell me how you feel about it. So here's Tom. I'm putting in my password for the first time. It's got some first-time installation stuff, like every other operating system. Every operating system is going to tell you hello, welcome. It's going to give you your, might give you options on setting things up and so on. And you got to wait for this to happen. Notice that it is still accessing the drive. This is a picture of the drive. It says, hey, do you want to connect your accounts? Doesn't this look familiar? Do you want to connect your accounts? Cool. Skip. I don't want to connect my accounts right now. Live patch. Canonical live patch helps your computer be secure by applying some updates that would normally require restarting. Would you like to set up live patch now? Highly recommend. I'm not going to do it here. I'm just going to click next, right? Help Ubuntu improve. You can give feedback. I don't want to send my system info. Privacy. I can turn off or turn on location services. Allows applications to determine your geographical location. I'm typically okay with that. Next. And I'm ready to go, right? You can use software to install apps like these, and it's going to give me some list of options. And I want you to tell me, guys, right, when it comes down to it, what you think of this. First of all, right-click, just like before. It's very similar to what we've seen. If I go to display settings, I can change my display setting because I'd like it to be bigger. So again, so right now my resolution is 800 by 600. We can move that up a little bit so you guys can still see more stuff. So again, what I want to do is just move up to, let's say, 1024 by 768. Okay. It says fractional scaling. Let's see what that looks like. Sure, let's keep these settings. That looks probably a little bit good. I can fit most of my screen so you guys can see it. Background, it gives me the cat, if people like the cat, and some other options, right, which is pretty cool. All right, so that's pretty good. I like that a lot. That it gives me this kind of option. Appearance, so standard or dark. I like a dark theme. So right away, I'm already happier with this than before because, you know, I'm a developer and I like dark theme nowadays. I guess it's just a thing. Auto hide the dock. I can hide it or not. Right there it is, just like before. So I can auto hide if I want, or I can leave it on, whatever I feel like putting it in there. Different notifications, applications, online accounts I can connect to, sound, screen display, what orientation do I want, my resolution, and a bunch of other stuff. Okay, so that's kind of really cool stuff. I can go to users, which might look very familiar to you, kind of similar to what we did already, and that's good. Default applications, you can specify which is your default browser, and this time it comes with the mail client. I don't have to install music player and so on. Cool. Updated software has been issued since Ubuntu 20.04 was released. Do you want to install it now? I'm going to say remind me later because we're not going to do that. And if you look at applications, now that came a little bit slow, but that's only because I didn't allocate a lot of memory to it. But you can see that it comes with quite a few applications out of the box. If I go to Ubuntu software, so it'll bring up the software store kind of thing. And this is pretty good. It's going to take some time for me because, again, you can see that this is doing its thing. Software catalog is being downloaded. It does this for the first time. But again, one thing I really like about this is kind of its friendliness, compared to some of the other stuff I want. I don't want my rhythm box. I want to remove it from favorites. Files I'm pretty good with. Thunderbird mail, I can remove that. I'm not going to do any mail right now. Firefox is cool, but let's say, for example, I want to download something else like Chrome. I can do the same thing. And you can see that it looks very similar. Krita, highly recommend. Get Kraken if you're using that kind of stuff. Visual Studio Code, it supports everything that the other stuff installs or supports as well. And it's very similar to our desktop. And again, it's the same command. So if I press, like my Windows command, my Windows button, it'll push up this. I can type in the keyword terminal. And now we're back to things that you might be happier with. But take a look. If I have a little colored command line, kind of thing from the get-go, which is pretty cool. It says to run a command as administrator, use user root, use the sudo command. So again, very friendly in terms of what it's telling you to do, right? One thing that you can't do is DNF. So you can't just do DNF. DNF is not found. In fact, if you go apt, then you can see that apt is the command that you want to use. Apt get is going to be the command that I want to use to get packages, right? So again, let's suppose that I want to download Visual Studio Code. Let's close down the terminal and go to Firefox. And again, I find that if I allocate more memory and more power to this thing, then it's a little better. But let's suppose I want to get download Visual Studio Code. And you can see that I have these options, right? So notice I have Debian, right? And I have Red Hat, Fedora, and SUSE. So notice like Debian and Ubuntu are here, and then RPM. So we're moving away from this type of distribution of Linux to this type, the Debian type. So we're a Debian base as opposed to the same Fedora, Red Hat, and SUSE base over here. So I'm going to click this, Debian. And it tells you, thank you for downloading. It tells me that you have chosen to open this. I'm going to open with my archive manager. Archive manager is like an archiver, if you will. I'm going to press OK when it finishes downloading. And yeah, right? So did it really do what I was supposed to do? Well, let's extract it. And it tells me where do I want it. I want it on the desktop. And it says extraction completed successfully. Show the files. And at home, as an example, I can go to, so these are my file system. If I look at desktop, my folder's empty, but home now has a bunch of stuff, documents, downloads, and templates, and videos, and everything else. And my downloads is empty, right? So where did this thing go? Well, it went to / right, for my my installation. And a lot of times what you also want to see is you can say, how do I install Visual Studio Code? Whenever you have some kind of new operating system, I always do that with it, like try and install the basic stuff that I know. So let's close these tabs. One thing to check is if it installed properly, then we would have it available if I search for it. So if I press this and I go Visual Studio, I would come up. But unfortunately, if I go visual, it doesn't know what the heck I'm talking about, right? So we know it didn't do what it's supposed to do, right? So let's just try this again. Let's go to command line, so term. And let's see what happened. So I've got control tar.gz, data.tar.xz, right? These are files, and I got a Debian library as well as a bunch of stuff. So obviously that download, although I downloaded it, I really didn't install it. So let's search for how to do that. And again, I'm just going to do this one thing, and then we're done for this thing. So again, how to install Visual Studio Code Ubuntu. Okay, so now it's going to give us some how to install Visual. Sorry, it doesn't matter where. It's Linux size, sure, and it talks about install VS Code on Ubuntu. Prerequisites before doing it. You have to have user sudo privileges. No problem. Hey, look at that. It gives me commands, and this is what I wanted, right? So I want to do this stuff. It basically tells me I need to do all this stuff. So let us pull this down and aside, and we'll do this sudo apt update. So sudo apt update is going to ask me to log in. Okay, so it does my update for me, right? And this update updates my the distribution links. And then it says apt install software properties common apt transport https wget. So it's basically installing wget. So I'll copy this, go back to my command line and paste, and then enter. And I probably should have put yes by default. Okay, it's going to install a couple things, just a couple. And the next one is going to be, I'm going to use the wget command. Once the wget command is installed, which it is now, then I want to use the next part, which is this command right here. Okay, so copy this one, go here, and then paste. Okay. Again, just following the instructions, right? And then the next one. Okay, there we go. Paste. Run it. So it's going to do its thing. And what this is doing, this next command, by the way, it's enabling it, the repository itself, right? Because that's where you get it from. And then this is the command we need, right? These commands. So again, once it's been done, I can just do this. We just do another update, check to see if there's any other updates. It's going to read it, and we're going to be good to go. We've already updated. And then just this. And if you follow that installation process, it's going to download code. It's 62 megabytes. And once it's done, it's been installed. Once it's done. So it's still doing its thing. It's getting its package, unpacking. But apt is the thing. Instead of DNF, we're using apt. But really, guys, at the end of the day, whether you're using apt, which is a program, or DNF, or NPM, or something else, or Homebrew, or whatever, as a manager to install stuff, does it really matter what package manager you're using? The answer is it doesn't. Right? It doesn't matter what package manager you're using. Okay. So if I go code now, then I should be able to launch code like before, right? And we should get Visual Studio Code. Yay. So that's pretty cool. It's exactly the same program that we would normally be used to getting here as before. Let me just close this off, and I will close this off. So it didn't take long. But one thing to note about all operating systems for Linux distribution so far is we need a bit of the command line to get things done. Here's what I like about Ubuntu. Take a look at this. I can minimize something, man. I can bring it back. I can maximize something. There's some controls that I'm missing that I was craving from a Windows perspective that I didn't really have in Fedora. It's there. You can do the same thing, but it's missing. It's like I want these little buttons, you know, or whatever. This is just me, right? That's how I feel. It's my preference. You might like Fedora better. I mean, it's totally cool, and there's a lot of people who do, right? So let's add that. We'll right click here and we'll say add to favorites because we're going to use this again. So we can do that right from here, right? And I can move this up because I know I'm going to use VS Code a lot. That's what I'll be doing for it from here. And the same thing goes with my terminal. If I access my terminal, and if I want to install my terminal here, even once it's here, I can just add to favorites, similar to what we do with Fedora, and then I can pull this up because I don't want to search for this every single time. I want to bring it up. I can also hide this. I can reposition my toolbar so it's at the bottom, right? A lot of people do to make it more Windows-like, right? So again, if I right-click, now there's two settings. There's display settings and there's settings. If I go to settings, it takes me to general settings. So here, right? So it talks about things like always show universal access menu as an example, and a bunch of other stuff. And there's my screen display, right? And then there's appearance, and it says auto hide the dock, and then position on screen. Okay, this is what I do a lot of times. If I use Linux, guess where I put it? Not the right, the bottom. So now, look, it's very similar to this, to what I like to do. Icon size. Let's make that icon size a lot smaller because you know what? I want it way smaller than I had it before, as an example. And now, you know, you know, your conversion is complete. You have come to the dark side, and now we're good to go. So, again, I just wanted to show you this as an alternate distribution for Linux. I think it's a good option. The fact that you can actually do stuff on the desktop, that's a really cool thing too, that you can't do really in Fedora. So if I want to put something like, you know, my workspace file, so if I say something like COMP301 in the summer 2020 semester and it's lesson 5, right, I can make a folder here on the desktop that I couldn't really see by default in Fedora. And if I want to do the same tricks that I do in Windows and launch Visual Studio Code here, right, and if I want to drag and drop in here, right, so let's say drag and drop, that's the stuff that I'm missing. This is the stuff that I crave, and this is the stuff that I can't do, right? Still not quite what I'd like, but I would like if I could do it. But one thing is we can actually see that the folder is there, and I can go to my desktop and I can look at this folder and press OK, right? So now I'm accessing the folder on my desktop. I can do some of the similar things that I did before. I can add folders, total folder control, like things like scripts for those people who are doing client-side web development with me. Clip, scripts, content, you know, as an example, we'll make another assets folder, you know, this kind of thing, and we'll even add a index.html file. Hey, why not? Just similar to what we did before when we were fooling around. Okay. I'm not going to install npm and yarn and node and all that stuff, but if I was going to use this system as a development machine, then yeah. So here's something that I'm going to offer you guys, because I'm going to put it out there too now, because we've installed Linux. For the second half of the course, I'm not going to specify which version of Linux you use. It doesn't matter to me whether you you use Fedora Linux, or whether you use Ubuntu Linux, or whether you use whatever version you want. Any version that's out there right now that you want to explore and use, if you're comfortable with it, even other versions, as long as you can use Visual Studio Code, because we'll be using Visual Studio Code from to learn Python in the second half, and so on. It's totally up to you. I'm totally fine with whatever version of Linux you want to use. And because I want to make this friendlier for you in terms of how it feels to run an environment. The other thing I also want to say is this. If you want to run Linux, Fedora Linux, or Ubuntu Linux, or SUSE Linux, or Debian by itself, if you want to run this in VMware, any virtualized environment, or even on the metal, without reinstall your system with Linux, and you want to do that. I mean, I don't recommend doing all that stuff because you need Visual Studio for programming. But if you had access to a second machine or something, and if you want to do that and do all the same things that I've asked you to do for your programs that you're going to write in Python in the second half of semester, to me it doesn't matter, right? Because at the end of the day, as we move out of using Linux and into using Python, it doesn't matter what version you use. Because take a look, if I exit from here, because I'm using Visual Studio Code next half of semester anyway, okay, I'm just letting you know. So not next week, but the week after, we're going to use Visual Studio Code, right? So if I go to terminal, as an example, and I type the word Python version, right, or Python, so it says, one thing it says, Python not found, did you mean Python 3 from Debian, right? So Python 3. My version for Python 3 is 3.8.2. Guys, that's the latest version of Python that we're going to be using, right? So it doesn't matter to me what you do. I think it's quit, if I'm not wrong, for Python. So it doesn't matter which version of Python you learn or you're using, as long as you're using anything beyond 3.7.5, it's going to match with the requirements of the course. So it doesn't matter. It doesn't really matter. One thing I will not allow you to do for next half is use Windows, because this is a Linux operating systems course. So technically, I'm going to need to get you to use Linux. So you're going to use the Linux operating system throughout the entire course, but it doesn't really specify which Linux operating system. So you can choose whichever one after this. Okay. Questions, comments, concerns, anything that we talked about today, because that's all I want to talk about today. That's more than enough. All right, so I'm going to open it up to time with Tom now. So I've got a booking with Joseph first. For the rest of you, please focus on your assignment number 2. That's where I think you should focus on first. I'm going to power this down. By the way, powering down is the exact same. Power off. Focus on assignment 2. Remember, assignment 2 is due next week, right? So that's important to get done. And since next week is the final week of Linux, we're going to be handling administrative tasks. I want to also set up a little server next week, like we talked about before. So I'm going to show you how to set up Nginx as a server, or use Apache. One of the things that it asks us to do is how to start and stop services next week. And one of the things we're going to talk about is how to start and stop an Apache server, how to start and stop an FTP server, how to install an FTP server, and all those kind of things. Because once you know how to do those things on one version of Linux, then you kind of know how to do it on most versions of Linux. Okay. Otherwise, guys, thank you so much, and I'll see you next week. I'm going to stop recording now, and I'm going to go handle some questions. Thank you.